All right, are we working? Okay. First off, thank you for sticking it out to later in the day. I'm an East Coaster, so I would normally be going to bed in like 30 minutes. So yeah, and no coffee for me before talking. So just a quick introduction about myself. I'm Dakota Riley, currently a staff security engineer at LiveRamp. And the easiest way to describe what I do is I'm a security engineering practitioner. I've worn a lot of different hats across cloud security, application security, always some kind of automation, more lately detection and response. So willingly or unwillingly, I've done a lot of random security stuff. And when I'm not doing that security stuff, I live in Northern Kentucky with my wife. I have 3 cats. I'm either playing video games or outside hiking. So just a quick agenda of what I'm going to cover in this talk. So as Frank mentioned, Kubernetes and cloud identity is really complex by themselves, and when they integrate together, it gets even more complex. So I'm going to talk about that. I'm going to talk about why we as security professionals should care about that. Before I go too deep down the Kubernetes rabbit hole, I will cover a brief primer of the things you need to know to follow along on the talk, specifically to Kubernetes and Kubernetes RBAC. I'll touch on something when you talk about Kubernetes and cloud provider identity that it's easy to assume either or cluster authentication versus workload identity. And then I'll cover it across how authentication works because there are some commonalities and how the authentication mechanism works across the 3 cloud providers. And then I'll dive into the nuances and edge cases of all 3 managed Kubernetes service offerings. And finally, we'll wrap it up with what you as a security professional can do to protect, detect, and respond on these things. So given that you're at CloudSec Next, it's very likely that you either currently or are planning to work with one of the 3 major cloud service providers, AWS, Azure, or GCP. And you also likely have teams that are building containerized workloads, and Kubernetes is the most popular container orchestrator. There was actually a 2023 study done by, I believe, Dynatrace called Kubernetes in the Wild, and they estimated that 73% of Kubernetes in the cloud is running on top of managed Kubernetes distributions and offerings. So with that, with managed Kubernetes, and cloud provider, you have 2 control planes, right? You have the cloud provider's control plane and its identity and access mechanisms. And then you have the Kubernetes control plane, which has Kubernetes RBAC. And then on top of that, you have those 2 things that are integrated that allow you to use credentials across those. And so the point of this talk is to try and demystify that to a way that us security professionals can kind of understand it, kind of touch on the edge cases or interesting things that might allow you to expose access in unintended ways and just how it all works. So again, before we go too far down the Kubernetes rabbit hole, I wanted to just cover the things you would know, the concepts of Kubernetes you would want to know for being able to follow along on this talk. So within a Kubernetes cluster, the simplest thing you can boil it down to is resources or objects. And you can think of those as like the Lego bricks that you use to express your application or cluster settings on the cluster. And those, an example of those might be pods, daemon sets, stateful sets, cron jobs. Those are workload resources. There's also settings resources like config maps or secrets. But depending on the type of resource, it can live at the cluster level or it can live at the namespace level. And a namespace is just a logical grouping for grouping resources that are of similar purposes together. For the purpose of the talk, we're not going to cover all the compute resources. The ones we care about the most are the ones that are related to Kubernetes role-based access control, or RBAC. So those are roles and cluster rules and role bindings and cluster rule bindings. And this is what a role looks like. So a role at its core is to assign permissions that you can take against resources in the cluster. So a role consists of, and this is not hard to say at all, of rules that say you can access this particular type of resource, this specific resource name with these verbs. And cluster rules are the same, except they live at the cluster scope, and a role lives at the namespace scope. And then the way these get tied to identities are through our role bindings and cluster role bindings. And if there's one thing you take away from this whole primer, it's this that you should, because this will appear in all the cloud service provider identity integrations that we talk about. But a role binding basically says this role can be utilized by these types of identities. So it might be a Kubernetes service account, For the purpose of the talk, we're going to see, different cloud identities referenced, and it's all defined by that subject field. And the same thing applies with the role binding versus cluster role binding. One is at the cluster level, one is at the namespace level. So, and then finally, the last thing I kind of wanted to touch on before we dive into the meat of the talk was a very similar concept. Because when you say, manage Kubernetes and cloud identity, you're generally referring to one of these two different things. So there's cluster authentication, and then there's workload identity. I wanted to incorporate both, but it's a lot to do both of these subjects in a single 30-minute talk. This talk's mostly about cluster authentication. Briefly, workload identity. So workload identity refers to the ability to grant applications running in the cluster, the ability to securely access cloud service provider or third-party APIs. If you've seen EKS pod identity or GKE workload identity, those are examples of that as a feature. Awesome concept. But what we're talking about today is cluster authentication. It's just basically the opposite flow, where I have a set of cloud service provider credentials that I'm going to use to authenticate to my cluster. And that doesn't necessarily have to be a human. It's easy to assume it's a human. That could be like a Lambda function or a GCP cloud function that maybe does administrative things to the cluster. And as I said previously, in terms of authentication, there is kind of a common flow across the three cloud service providers as how this works under the hood. So if you've interacted with a managed Kubernetes cluster before, you might have seen these commands in your respective AWS, gcloud, Azure CLI that equates to getting a set of credentials to access your cluster. And for me personally, I learned about AWS and how that works and the mental model of that first. So I thought, hey, there's probably an API named update kubeconfig, and it turns out, and this is consistent across all three. There's not. It's actually doing something completely different under the hood. So when you call one of those commands, your CLI tool is actually going to hit a separate API on the cloud provider side to get some metadata about the cluster, which includes the certificate authority information and the address of the control plane endpoint. What it's going to do once it gets that, it's going to generate a kubeconfig file locally on your machine, and that looks something like this. So at the top, you can see basically that metadata information that I was referring to that it collects, basically to tell it, hey, this is where the cluster's control plane is. I removed the certificate authority data, not because it's secret, because it's not, but more because you wouldn't be able to read it because it would go all the way down the page. And then the next interesting thing about this that is, again, consistent across the three cloud service providers is when it creates this kubeconfig, it includes what's called a client authentication command. And this tells kubectl how to use your cloud service provider credentials to make requests to the cluster. So in the case of GKE, there's like a compiled binary that basically just understands how to use Google Cloud Creds. I think EKS has a get token command that it embeds in there. But it's also neat too because this is a native pattern to Kubernetes. This isn't a hack. They support these custom authentication plugins, and that's how all three of these work. So finally, once you have a generated kubeconfig and you run kubectl get pods, it's going to execute. It's going to use that client certificate credential or client credential plugin to get your cloud service provider credentials and access the Kubernetes cluster. On the cluster side, and all the kind of dirty details of this aren't super publicly available, but the Kubernetes documentation basically alludes to it's a webhook authentication plugin that understands how to interpret those cloud service provider creds or forward them to the cloud service provider's identity plane. So with that, we talked about how they're similar. We're going to talk about the nuances of each, starting with Amazon Elastic Kubernetes Service, or EKS. And when it comes to interacting with an EKS cluster with your Amazon identities, you can map AWS IAM principles, so your users, groups, or roles to Kubernetes roles or cluster roles. And there's two methods for doing so. There is a legacy option now known as the AWS Auth config map. And there is an option that was recently released, I want to say about half a year ago, called EKS access entries. And before I go deep on this, some of you might be like, Dakota, why are you talking about a legacy option? But the reality is that if you have EKS clusters that have been running longer than a year, or if you launch them, you can actually run both of these options side by side. This probably still exists in your org. So, legacy, but, and it's deprecated per the AWS documentation, likely still relevant to us as security professionals securing managed Kubernetes clusters. The way this works, it uses what's called a config map, which is another type of Kubernetes resource that's just designed to store configuration data. It's on the cluster, it's in the kube system namespace, and it stores mappings of AWS IAM principles to subjects, group names of role bindings. And I'll show an example of that after this before we touch on the two interesting edge cases that you'll find about this. And I've seen some funny horror stories, I guess, depending on your perspective, is that when you create that EKS cluster, if you've enabled the AWS auth config map, the identity that's creating the cluster gets implicit access. It's not mapped in the config map, anything like that. I've personally seen a scenario where somebody broke that AWS auth config map and had to go and search for what identity created the cluster to regain access to it. I think that has interesting security implications too, because you have a role that somebody might have forgotten about that could be privileged. And interestingly enough, if you migrate purely to access entries, which is what I'm going to talk about next, that access persists. And so this is an example. On the left side, we have a cluster role binding where we're referencing a group subject, EKS console dashboard full access group. The name just has to match between the two. And then in the config map, we're referencing that same group name and we're tying it to an IAM role. Optionally, we can specify a username that just controls how that propagates in the Kubernetes audit logs themselves. So moving on to EKS access entries. And your second thought might be, why is there two methods? And really what makes EKS access entries or the EKS access entries API different than the config map is it's no longer managed on the cluster. It's part of the cloud service provider's API. It's part of the EKS service. The other improvement over the AWS Auth config map is that implicit access, assuming that you only use this, because you can create the cluster and say only use access entries. There's no implicit access. You have an option to automatically create an entry for the creating principal, but it's a win for security because we're not accidentally creating access and forgetting about it. And the way we authorize requests in the cluster in this case, there's two methods. There's a new feature called access policies, and all access policies is they're a cookie cutter set of cluster permissions that tie to admin, view, edit, and then there's ones for specific services and specific service use cases. And you'll see this as a common theme, but these are great for getting started, or if your access requirements aren't super granular. You can't create your own access policies and you can't edit the out-of-the-box ones. However, you can still map access entries to Kubernetes roles and cluster roles via role bindings. And this is my favorite part about each section, is that these methods actually allow you to grant cross-account access. They're almost like a pseudo resource policy, right? And as a longtime practitioner before getting into Kubernetes, that was really surprising to me. I did not know that. Now the caveat is that EKS CLI command update kubeconfig doesn't work, and it's the same with gcloud, which we'll talk about and all that stuff, because the API it needs to collect the metadata to generate the kubeconfig is not shared outside the account. So you have to generate the kubeconfig yourself. And while I'm here, I wanted to give a shout out to one of my favorite adversary emulation tools, Stratus Red Team. It actually has these baked in as techniques. So if you wanted to go back to your environment and test, hey, do we detect this? If somebody were to leave a backdoored AWS Auth config map, you can download it and detonate it. So moving on to Google Kubernetes Engine, or GKE. Having kind of, I guess, grown up on EKS, GKE definitely felt like the more native in terms of identity integrations, probably due to the fact that Google Kubernetes was born of Google, right? So it's mostly out of the box, and the two ways to authorize access are you have the actual GCP IAM policy itself, or you still have Kubernetes RBAC. So with GCP IAM, you can literally assign permissions that are basically modeled after your APIs in the Kubernetes control plane. I know the text is a little small, so if you look over there and if you're a little familiar with GCP, you'll notice those are not GCP services. Those are Kubernetes APIs where it's like container.pods.git, which is really interesting because you can manage that level of access outside of the cluster. The same caveat applies here, though, that You can't get super granular with it. So if you create a role that has these permissions, you use one of the predefined roles, it's project-wide scope. So, and it all depends if you have a multi-tenant environment or a single-tenant environment, or if you have multiple GKE clusters in a single project, that might have implications for your team, or it might not. It might be perfectly acceptable, depending on the details of your environment. And then you still have the ability to use Kubernetes RBAC directly. In this case, it's pretty seamless because all you have to do in the subject field, you can directly reference Google Cloud Principles. So, an email address of a Google Cloud Principal or a service account. A group is the only thing that requires any actual configuration. You have to configure a root group and nest it in there, but really, really easy to work with. And then again, interesting security edge case is that using the Kubernetes RBAC method, you can grant cross-project access without an explicit invitation to the Google project. And I recreated this because I was really surprised by it. I just had a friend create a Google Cloud account with his email. I added him to a cluster role binding with cluster admin, and I gave him the kube config, and it works, right? There is some caveats to this that I'll talk about in the prevent section, but no project invitation required. So it's something to watch out for. And on top of that, the folks at Orca Security not too long ago released some research they were calling sysall. And what their research centered around was the system authenticated default group in Kubernetes. And one might assume that in the context of Kubernetes, system authenticated means authenticated in the context of the cluster or authenticated in the context of whatever identity service I'm using. And in Google Cloud, it actually means any Google user. And I actually threw in the kind of the response from Google on this because it was twofold. They deemed the system authenticated group as intended functionality, but what they did do is they put in a guardrail to prevent people from accidentally mapping it to cluster admin, because I guess Orca had actually scanned the internet for these clusters and found, in the thousands that had some level of privilege mapping exposed to the internet with an authenticated Google account. So yeah, fun stuff. Yeah. And then finally, Azure or Azure Kubernetes service. And if you're familiar with Azure, you probably won't be surprised that there's two methods of authentication. The first is local accounts, which I'll talk about first, and then like most Azure ecosystem things, you have the ability to integrate with Entra ID. And then for authorization, you have the ability to use Azure RBAC with Kubernetes permissions, or fall back to Kubernetes RBAC with mappings. So local accounts, this one surprised me as I stumbled upon it, but these are basically client certificate credentials. So the way they work is there's a command for get credentials, and if you don't have the Entra ID integration turned on, you actually get a static credential back for either a cluster user or a cluster admin. And from a security perspective, this is scary for two reasons. One, because I believe that credential does not get rotated unless you rotate the cluster certificate. And on top of it, if 5 people on our team grab that and start doing stuff in the cluster, there's no way to identify who did what. The only thing you'll get is you'll get the audit log on the Azure side that they initially retrieved that credential, assuming they didn't save it somewhere, right? And then everything in the Kubernetes audit logs would just be cluster admin or cluster user. So, if there's one thing you take away from this talk and you're in Azure, I'd recommend you disable that. Great use case for detective control here on the usage of it or in the enablement of it altogether. And the other option, the Entra ID integration. So the Entra ID integration is relatively straightforward. The only thing you have to configure is the presence of an admin group. So when you create that admin group, it does not, again, it has no explicit mapping in the cluster. It's granted administrative permissions. So if that's something you're doing, you want to keep track of that and kind of treat it as a privileged group, especially if it's tied to clusters in production. Otherwise, the mapping of groups is really straightforward. It just comes down to taking the group ID and referencing it in the subject of the role binding or the cluster role binding of where you want to tie those permissions to. And then, instead of Kubernetes RBAC, if you want to manage it at the cloud service provider level, you have the ability to use Azure RBAC. So, and it's similar to GCP IAM, where the cluster permissions are expressed as, Azure RBAC permissions. They're considered data actions under the Microsoft Container Service, I guess, namespace. So, for example, like being able to read pods would be expressed as Microsoft Container Service managed clusters pods read. And the scoping, again, goes back to it can be scoped to an individual cluster, a resource group, or a subscription. and the usage of it does not negate Kubernetes RBAC. They kind of fail. It will fail back to that if it's not permitted by Azure RBAC. So to this point, uh, I've talked about all these weird edge cases that you can trip over, how you might over provision access, or all these bad things, right? So what can we do as security professionals to deal with them or audit them or handle them right? And from the preventative standpoint, the first thing you can do is, as much as I hate this kind of like network allow-less control in 2024, if you have to keep the cluster control plane public for some reason, there is the ability on most of the managed Kubernetes services to do IP CIDR allow listing against that. The other option, especially if you're a little more mature on the network side, is you can typically restrict usage of the cluster control plane only to be within a VPC or a virtual network, and then from there you control the routability and reachability of it altogether. The second, and with all things IAM or maybe security in general, is that it's just cheaper to do it correctly the first time. And a lot of times, security teams or even cloud security teams, we don't own these configurations. It usually falls to an infrastructure ops or SRE team, and it's to partner with those teams in the creation process, right? Whether that's coming up with like sets of permissions that might map to developers versus SREs or on-call team. That's the other option, is to just do it correctly the first time, partner with them early in the design phase. And then from a detection and monitoring standpoint, there's two pieces to this, because again, the core theme is you can manage Kubernetes clusters permissions at the cloud service provider level or at the cluster level, or both. But if you're managing them at the cloud service provider level, it comes down to a very similar workflow to if you've done any like cloud security posture management type work. EKS access entries, GCP IAM, Azure RBAC, they're all cloud service provider APIs. So, it could literally be as simple as having, a Lambda on a cron job that describes the state of those access entries and alerts you when they deviate from your desired state. You also have the cloud service provider audit logs like CloudTrail, Cloud Audit, where you could just alert on deviations or records created on those that don't match your security posture. And then for cluster level configurations, it's a little trickier because, one of two things have to happen. Like if you're going to actually audit the state of that object or those role bindings, you have to authenticate to the cluster. So for EKS, the AWS auth config map, it could just be describing that config map and looking for entries that are unintended. With GKE and AKS, they rely more on the role binding and cluster role bindings. So that could be a matter of describing those objects and looking at the subject fields for kinds of user or group, and mapping those to an intended set. That, or plumbing the Kubernetes audit logs and looking for changes to those objects. So we're at the end of the talk here, and I just wanted to leave you with a couple points here. And it's definitely complex. There's a lot going on in hindsight. If I could rename the talk, I would have named it Kubernetes and Cloud Provider Identity Spaghetti, but I didn't have that option. But I'm going to say this: I actually don't think one method is necessarily better than the other. It all depends on the context of your environment. If you have like a multi-tenant cluster environment and you have some really specific access requirements, you might want to rely on Kubernetes RBAC, where you can do access at the namespace or the resource level. It's also totally possible that maybe you don't have as much focus on that, and you guys have a really strong, AWS account, Google Cloud Project, Azure subscription, kind of blast radius strategy already built out, and you're comfortable with kind of delegating that to the cloud service provider level. But again, it all depends on your environment. And if anything else, if you have managed Kubernetes and you're not looking at the stuff today, it probably deserves a spot in your backlog or risk register. So that's the talk. If you enjoyed it, the QR code is for my LinkedIn. Love to connect. Thank you so much.